Hey everybody, I'm writing a quick answer key for this review worksheet. Can't write and talk at the same time. 5 problems to hopefully review most of this chapter. This is pretty straightforward. It's all about parent functions and moving them around. You should know those fundamentals, page 170 in the textbook. Here we have our our parent function. I'm just going to put this right here in the middle. There's our x-axis, there's our y-axis. I don't know why we didn't put those things in before, but oh well. The original parent function is just an absolute value. It makes a straight V based on the fact that this is your y equals x line, and then the absolute value bumps all the negatives up there. So that's pretty easy to picture. But what's happening to it here, this -3 flips it, flips down, flips over the x-axis, and then stretches by 3. Can't write that out quickly, but then the x minus 2 moves 2 places to the right. I'm going to just keep it quick. And then the plus 5 moves it up 5. So it takes and makes this stretch down so that you go over 1 right and left, and you go -3. That's an easy way to remember it, a little bit like slope. Over 1, and I go up or down, whatever that value is. It's -3, so I go down 3, over 1, to the left side, down 3. So now this moves 2 to the right. That's with the x minus 2, and then up 1, 2, 3, 4, 5. And now I'm going to repeat the over 1 in both directions, down 3. Okay, so you should be able to move those things around pretty quickly. Practice that. Desmos can help you practice that skill. Okay, now we're sketching based on these criteria. It starts off with f of 5 being equal to 3. I'm going to move it just a little bit this way. And so there's my y-axis, there's my x-axis. So I'll go 1, 2, 3, 4, 5, and I go up 1, 2, 3. So I know that the function goes through that target point. It's concave down for all real numbers, so you can kind of think of it maybe as being like concave down like this, except hold on, there's a vertical asymptote at x equals 1. So make that asymptote, remember it cannot cross that. It has to follow up close to it. So it's got to be like this and then like that, at least in the basic concept. That's how something can be concave down. And then it's decreasing for x is less than 1. Oh, so it's never increasing. So you can't have something like this. But once when you start decreasing, I can stretch that sort of that way. So it looks like it's going to be maybe starting up high and just coming down like that. We don't know. It looks like from this point, it's going to be going down like this. So it's decreasing decreasing when x is bigger than 5, and it's increasing between 1 and 5. So it's going to be increasing up to 5 and then decreasing. Then we're looking at the end behavior, it's called, as x gets closer and closer to, well, it gets bigger and bigger, not closer to anything, it gets bigger, flat out getting towards positive infinity. This graph plunges to negative infinity. That makes sense. So we know it's doing that. Then as x goes to negative infinity, it gets closer and closer to a fixed number. So what that means is that it goes like this, and then it flattens out and follows that fixed number, y equals 2. So that is giving me a lot of really good information. Where exactly it does the curve is not that important, but it approaches that asymptote, flattens out towards 2, and then plunges down. And then as x gets close to 1, the function gets close to negative infinity. That makes sense. From both sides, it's diving downwards like this. All right, so I've kind of made that a little bit messy, but basically it looks like that. No other options. So now, what is the range? The range is where I'm going to find my y values anywhere below positive 3. So f of x has got to be less than or equal to 3. What is the domain? The domain is you're allowed, it's not even asked. Domain is all real numbers except x cannot be 1. What is Is there a horizontal asymptote? Yes, there is. Horizontal asymptote at y equals 2. That's the horizontal asymptote right there. Okay, looking over here, this should go pretty quickly. Is this a function? Does it ever fail the vertical line test? No, it never fails. This is the only part that is suspect, and that is an open circle, and it does not collide with that closed circle. Does not exist there, but it does there. Still only 1 point. Does it matter if there's a gap there? Nope, gaps happen all the time. Happened on this problem right here where we had the asymptote. We can have gaps. So what is the domain? I'm going to say the domain is x is trapped between 1 and 5. 1 and 5. It can be 1, so bigger than or equal to 1, but it can't be 5, open circle. Then it can be 6 and go up to this, it can be up to 12. So x is trapped between 6 and 12. Similarly, it can be equal to 6, but it cannot be equal to 12. The range then, I'm going to find y values at 20 and at 10 and everything in between. So f of x is trapped between 20 and 10, and it is allowed to be equal to. So those inequalities are important. Get those right. So it is a function. So I'm going to circle is. Then here we've got function notation practice. What is g of 9? I plug in 9. I plug in 9. G of 9, that's the square root of 9 is 3. 3 minus 5 is negative 2. So it's the same as f of negative 2. When I plug in negative 2, I get 4 times 3 is 12. It's lucky 13. Okay? This is the same thing, slightly different notation. I just do f of 4 first. When I plug in 4 here, I get 16 times 3 is 48, plus 1 is 49. So that's really g of 49, very convenient, because the square root of 49 is exactly 7. When I take away 5, I get 2. All right, so how do we find the inverse of these? Well, you can just think in reverse if you want to. I like this method where you just say, like, if I'm that x, if I'm plugging in an x, what do I do first? First thing I do is I square it. The second thing I do is I multiply it by 3, times by 3, and the last thing I do is I plus 1. Now I'm going to undo all of those in the exact opposite order. So undoing a plus 1 is minusing 1. The next thing I'm going to undo is the timesing by 3, so I'm going to divide by 3. And the last thing I'm going to do is square it, so that's square rooting. So that means that this inverse function will be x minus 1 divided by 3 and then square rooted. That's how you do it. If you want to do it a little bit longer method, I'll show you over here in the margin. I just recopy this as y equals 3x squared plus 1, and then I switch the x and the y, so I have x equals 3y squared plus 1, and then I just solve for y. I want to get y by itself. Y equals, well, how do I do that? We've seen this before. X minus 1 equals 3y squared. I divide by 3, and I get then y squared is equal to x minus 1 over 3. So then again, I just square root that. X minus 1 over 3 square rooted. Same thing. So I'm going to go faster on this one. You can do it slowly for yourself, but this is only 2 steps. If I plug in an x, the first thing I do is square root. So the first thing I do is square root, and then the next thing I do would be plus 5. So I'm going to switch that. So I do the opposite, minus 5, and then I square. I raise it to the second power. So this is going to be x minus 5 squared, and that is the inverse. All right? Last thing is, write 3 equations that will intersect as many green globs as possible. Here's the example. I'll talk you through the example again. This is working just with transforming functions. This is, left out nope. This is supposed to be an absolute value. That got left out. I'll print a better version of that. Absolute value. And what this is, that absolute value, just like the very first problem, it's been moved 3.5 to the right. It's been moved only a quarter up, right about there. It has then every one I go over, I'm going to go down 1 1/4. I go over one, I go down 1 1/4, go over one, go down and 1 1/4, and then I'll be drawing that. And I think it's supposed to just go through both of these. We'll see how good that is. You can also say down 5 from here, 1 2 3 4 5, and over 1 2 3 4. Yep, I think we're going to get a direct hit on these 3. So you write your own equations. You can do a very skinny parabola that might go up like this and come down. Unlikely to get this one because that's directly below, but maybe you could go through, whoops, maybe go a little, put it the vertex over here, get a little wider. Anyway, you be creative, write 3 equations, try them on Desmos. Good luck.